All right, it is 2 o'clock, so we can go ahead and get started here with the restream. So we're broadcasting the sections that basically after our break that we had last Wednesday. I went into some more depth on a few sketch tools. So in the first half, we kind of covered basic sketching within SolidWorks, all the different basic tools that we have. Let me switch over here to SolidWorks so you guys can see. Some new part should be opening up here in a second. So we kind of talked about most of the stuff in here. So lines, rectangles, arcs, all that kind of stuff before the break. And then after the break, we talked about, the stuff on this half here. So all of this stuff. So we're going to go ahead and I'm going to rebroadcast this. Hopefully the audio works this time. I'm looking right now on OBS and everything looks good. So, feel free to drop something in the chat. I'll be watching as it goes live. If there are any audio issues or anything similar. So we'll kind of jump back in. I made myself a little outline, so I should be covering the exact same material as before. But kind of last time we were just messing around with just a random sketch on the top plane to illustrate a lot of things. We'll continue doing that. And we'll start off by talking about trim entities here. So we talked about this stuff before, moving on from trim entities onward. And I can't remember if I covered this in the second or first half of last week's session, but the S toolbar is very, very useful. Actually, I believe you guys can't see it. So by pressing S, if you are following along within SolidWorks, by pressing S whenever you're in a sketch, brings up a little toolbar of a bunch of more common commands. So you have your line tools, rectangles, all that kind of stuff kind of pops up right next to my cursor. Seeing it now in my preview, it looks like it's not popping up, but still trying to figure out how to stream a display. OBS doesn't like me, but I guess I'll just hover over here. So we'll pull up a line. Gonna make a big mess of lines, however we want. Cool. And then to illustrate kind of the use of the trim tool, there's a couple of different things we can do with the trim. So this power trim is selected by default. That's kind of very rarely you're going to need to go and do something besides power trim. We can kind of see from the icons here what they all do. So power trim or corner trim here, if you have two lines that kind of extend out, I guess I'll do something like that. If I need to do a corner trim those two, and it kind of, you need to select, kind of show by the blue dots there. That's your two mouse clicks. So it's clicking these two things here, and then it's trimming away everything else. So these are the two parts you're keeping. Trim away inside. It's, between two lines. I think I have something here. So yeah, I got these two lines. I'm going to trim this bit away because that's inside those two lines, or that bit there, right? So again, kind of shows you what to click, and then these two lines here, you're clicking those. All right, trim away outside, same thing. It just trims away everything outside, and then trim to closest would be this one here. So it trims it to the closest entity there. But the really nice thing about power trim is it does all of those things and more. So let's kind of roll back to the big mess of stuff we had before. I'll add that other last line. So hopping back in, power trim. Basically, you're going to click and draw a line through all of the stuff that you want to cut away. Just start clicking, dragging, and it's going to just cut through everything that you draw your little path through. Just like that, I can clear out the whole sketch, right? Just undo that real quick, pop back into trim. It'll do that trim away inside. Let me go back there. It'll trim away the inside that we showed before. It'll do a corner trim for you. It gives you a whole bunch of flexibility all by just clicking and dragging your mouse through the stuff that you want to cut away. That being said, trim tool is also powerful in that anything that you cut away, if you cut away a bit too much before you let go of your mouse button or mouse click, you can bring certain parts of it back. So let's say, again, I'm kind of going ham and drawing through and cutting away everything. You can see a little red square that pops up right there as I kind of cut through a line, a little red square. If I hover back over the red square, it kind of undoes that cut operation, and brings back that one sketch segment that I really wanted to keep. Or I can keep going all the way back through until the start of my trim. So again, power trim, super useful, super powerful. Really do a lot of different stuff with it. This is kind of an abstract example of what we could do with it, but just to give you something a little bit more concrete, let's say we draw a circle. Basically we're going to be drawing a shaft, say a 25 millimeter shaft, roughly 1 inch. And we're going to be machining a flat into it. And this is something that's fairly common if you're kind of making a shaft that you're going to attach a gear to, or something else is going to slide on, and you don't want whatever is going on that shaft to be spinning on its own. You want it to spin with the shaft, so machining a flat's a good way to do that. Keyway is another good one. But yeah, so I'll draw my circle, figure out the dimension of my shaft, or the diameter there, and then we have this keyway. Keyway, I'll show you guys how to do these dimensions later, but keyway is going to be 3 millimeters away from that face, and then boom, click and drag, and it gives me that shape. But one of the things that I like to do, and it can be fairly good design practice, is to kind of leave, we want to communicate that the shaft is still circular to start, and we're cutting away part of it. And without just us knowing about the manufacturing process ahead of time, might not be super obvious. But there's this little checkbox here. It says keep trimmed entities as construction geometry. What that means is as I drag through this, you're going to see that the line is still there. It's just now a thin dashed line, which means it's construction geometry. When we go to extrude this or turn this into a 3D object from a 2D sketch, that line is not going to be extruded at all. It's just there, again, as construction geometry. It's a helper, helps you communicate the design intent and a couple other values about this part and the sketch. Another checkbox here, ignore trimming of construction geometry. This one's really helpful if you have really complicated sketches with a lot of extra lines that help define tangencies or, again, communicate the design intent. And you just want to trim away just your model items. So these actual solid black lines, if I go and start trimming through this, you can notice that it's only going to trim away. It's not going to trim my construction line. No matter how hard I try, it's not going to get rid of either of those. And then again, just to illustrate that trim entities, you don't have to have both these checkboxes selected. I can just ignore the trimming of construction geometry and then just completely get rid of that line. So that's all there really is with trim entities. And now we can kind of talk about offset entities. Offset just takes the sketch path that you have and it offsets it either outwards or inwards. So let's say that I wanted to hollow out the inside of this keyed shaft, and I want it to be a constant thickness all the way around, or maybe I'm referencing off of it to something else. So my parameters here, what I can adjust, this is my offset dimension here. So let's say that I want to offset about 3 millimeters into the inside here. Usually I want to just have it add in the dimensions for me. It'll just basically do a 3 millimeter dimension from one of the things that I select inside or towards my offset geometry. So I'll kind of just click that line there, and you can see it starts to give me this yellow preview of where it's offsetting. Like I said before, maybe I want to kind of offset to the inside of the shaft. So this reverse checkbox lets me do that, lets me control which way I'm offsetting. Select chain. This basically means that by selecting just the line itself, I can, it's going to go through and actually select this whole path. You can see it's selecting the arc as well. If I uncheck that, it's just offsetting the line. And then bidirectional, like I was talking about before, this reverse checkbox. Checking bidirectional gives me both. You can see it grays out the reverse option there. So it's actually going to give me the inside and the outside offset. Like I said, I just want the inside here, so I'm going to keep that. And then, kind of just to illustrate a point here, instead of selecting that line, I'm going to select this arc. I'm not going to do select chain, so it's just going to offset this arc here. And then I have options to cap my ends. And what this means is you can kind of see the preview there. It's a fairly helpful tool to have the preview up. But essentially, as it's offsetting this arc here, and then it's adding in a cap, so some arcs on the ends that are going to connect my offset geometry in yellow to the original geometry that I selected, and it's kind of highlighted in blue here. It can either be an arc, so it's going to be tangent to both the offset and base geometry, or it can just be a flat line. So these are useful for things. In this case, it wouldn't be really useful to us. That's why I said I'm just going to use this as kind of as a demonstration tool rather than to actually. Remember, we want to actually do this here. We want to offset the geometry inside, but there are times where you'll just draw a line or maybe a spline. You just want to offset it to give it some thickness, and then you want to cap the ends. You don't want to take that extra step of just going in and drawing a couple of lines, because if you're doing that a lot, it saves you time in the long run. And then we have this last option of creating construction geometry. So with these two options here, the base geometry means that the lines that we selected after we do this offset operation, they will become construction geometry. So this is useful if you have a sketch that kind of, let's say that you have a hole that you're trying to put a certain shape plug into. You don't want that plug to be the exact same size as that hole. So you draw in your hole, and then you want to offset it, maybe a millimeter or so, just so it has enough clearance to fit in there. So you drew in let's say that this outside shaft area was your hole, and then when you go and click the green check mark, you can see this outside edge is now construction geometry, and now this is actually our model geometry. So if I do the opposite here, and offset entities, still selected that, reverse. Instead of my base geometry, I now have my offset geometry that becomes construction. There we go. So this is like, I'm saying later on down the line, maybe it'll be hollowed out, or I'm kind of just using this to dimension off of, or whatever else. So you have these options to, instead of creating the offset geometry, then going through later on and making a construction, the tool does it all for you, which is pretty nice. So that's offsetting entities. And before we kind of dive into more stuff, these other things here, we kind of need to talk about dimensioning and relations. So I'm just going to grab a quick drink here. All right, so talking about relations and dimensions. We'll start with the relations. So the relations and dimensions are, if we think about our first session that we had talking about geometry and topology, topology being kind of just how many faces and edges and vertices does this part have. Geometry, or we turn that into geometry by dimensioning each of those vertices or edges or the faces and how far apart they are. Or also, if they're parallel or anything like that. So usually a good rule of thumb is to try and add relations first and then dimensions. And we'll kind of start to look at what are the different kinds of relations that we can have, just for a simple line. And I just drew this line, it's pointing arbitrarily out in space. I'm going to click on that line to bring up its properties. I think we've talked about this before. But you have this little toolbar here, shows you which relations you already have. And then you have the option to make it either horizontal. So that's a relation to the model origin itself in your reference coordinate system. So horizontal is along X in this case. I also, you can see up here, now that I've added in that relation, if I click on it, or if I click on the line, it brings it up in green. If I want to highlight that specific relation, because sometimes you'll have like 4 or 5 different relations on a single, in a sketch, or just referencing to a single line, sometimes more. You can see it's horizontal there. So I can press the delete button, not backspace. It has to be delete, I'm pretty sure. And then I can make this line vertical. And then again, clicking on that, get the little green box here. If I hover over it, you guys aren't going to see it on the stream, unfortunately, but it's hovering and showing me vertical, and I can click on that again, and it'll show me that as well. And then, so if I delete that, and then let's say that I go kind of arbitrarily out here, and I don't know, maybe I turned around whatever else in my model. Can't remember, which way I'm facing. If this is, if I want this, if I want this to eventually be up here, right? And I can't remember if that's the vertical or the horizontal dimension, or kind of which way it's pointing. If I click on it and then hop over to here, you see that vertical is bold, so I can click on that, become vertical, right? And that way, so it's highlighting in bold the orientation that it's sketched closest to. So usually, kind of a good philosophy is when you start sketching in kind of your topology, you want to make it fairly close to the actual shape that you want it to be, and to the actual geometry that you want it to be. Like if you have a line that's going to be 25 millimeters and another one's going to be 50, you want to kind of draw the 25 millimeter about half the size of the 50. And same thing if you're going to have angles, or one thing's going to be vertical, horizontal, you want to draw it fairly close to what you're, fairly close to the end results, that as you start to dimension and add relations and stuff like that, it's not going to change up too much on you. So that's just for one line on its own. The only relations we can give it are going to be to our reference axes. This fix relation, I want everybody to pretend like it doesn't exist, because it's not. It's very rarely is it good design practice to fix something with this fixed relation. What I mean by that is, usually we want to go through and actually say, hey, this has a very specific angle to the origin, or to this other construction line, and it has a specific length. By clicking fix, it just, whatever I drew that line as, it's going to fix it as. And usually it's just the angle here. The length is still unconstrained, but if I were to fix this point in place, it's just there. I don't know how long this line is. I don't know what angle it is to anything. I just know that it's there, and I fixed it in place. And you can see how just by drawing in a bunch of stuff and fixing it in place, it's not really going to help me, be able to go back in and make changes. When I go to manufacture it, it's just like, I just drew this line. It's some length that I sketched in. I want to actually have a value to that length that, it's going to be milled out to 50 millimeters, and this hole is going to be, that dimension, whatever else. So that's there. There's a couple other relations that we can start to talk about. I think the example that I used in our session on Wednesday was a parallelogram. So I'm just going to draw a really sloppy parallelogram. Again, we want to draw stuff fairly close to what it's going to be as when we start to add relations, but I'm going to make it sloppy on purpose. So this parallelogram, I want this bottom line to be horizontal. So I'm going to go ahead and hop over here. See, it's bold because it's closest to horizontal. So I'm going to click on that. And again, since it's a parallelogram, top and bottom line should be parallel. So I can do one of two things here. I can either make this top line horizontal, or I can make it parallel to the other line. And that's usually what I want to do. If there's two lines that need to be parallel to each other, it's best to kind of say, hey, these two lines are parallel to each other, and then give an angle to one of those lines. So actually, the better order of operations here would be to Control-click to select both of those lines, make them parallel, and then go in and click on one of these lines. I'm just going to click on this one because it's close to the origin, or it is actually coincident to the origin, and I'm going to make that one horizontal. You can see now both of those are horizontal. These two lines here should also be horizontal, or sorry, not horizontal, they should be parallel, but also they should be equal in length. Geometrical property of parallelograms. In this case, I can do either one of those, and I can kind of decide which of these matters most to me. It all depends on the part that you're designing. Sometimes it's just arbitrary. I just want both of these to be parallel, so I'm just going to click parallel. and boom, I have my parallelogram that I can drag around now, right? I can also go through, let me just make sure. Yeah, so I can also go through, select both of those, and make them equal to each other, and gives me that same exact result where I can just drag this around and those stay parallel to each other. The other thing, and geometrical properties, by making the top and bottom lines equal, I can make those two parallel. So again, few different ways to set up and kind of create the same geometry. Sometimes you will come across that and you just have to kind of, sometimes it's just, whatever is most convenient, whatever gets the job done quickest. Yeah, so there's that. And then let's see here. So and then kind of at this point I've defined the relations between the lines themselves. Now I actually need to give these some dimensions, and I can do that a few different ways. So let's say that this parallelogram, I know that this line is going to be 30 millimeters long, and that's a critical dimension. So whatever this part is actually going to end up looking like, I don't know, but this line is going to be 30 millimeters, and this line here is going to be 20 millimeters. Then I have to figure out the angle that this parallelogram makes here, the included angle here by the origin. So with that, I click on one line, I click on another line, and then I can place my dimension anywhere. So it gives me a degree dimension here and make it 60 degrees. Cool. Now you can see at the bottom of our sketch, we are fully defined. So we've done enough dimensioning and relations that nothing in this sketch can move. It is fully defined as geometry, and it's no longer just arbitrary topology. So this is our goal with all of our sketches, is to always have fully defined sketches. There's a few exceptions that we can make to this, but for the most part, anytime we draw something, we want to go through, add in all the relations, add in enough dimensions to where all the lines turn black. So now, kind of the question that I pose in my workshop is, well, what if I don't want to define the included angle? I actually want to figure out what this is from the vertical instead. So I'm going to go ahead and delete this dimension here. And then I'm going to draw in a vertical axis. So if you remember what we talked about lines, we have our center line, which basically just gives us a construction line. And it's arbitrary length, doesn't actually create any geometry. Usually I like to make them the same length as this, or kind of the same height as my parallelogram. We'll talk about that a little bit here in a bit. But again, arbitrary length, I'll just kind of draw it in there just so it's there, and I can click and drag this dimension out of the way. So now I can do the same thing I just did. Maybe I want this to be 32 degrees off of the vertical, and I don't want to go through. Engineers are fairly lazy; they don't want to go through and do all the math every single time and be like, all right, 32 off the vertical, that means that's 58, included, and this is a fairly simple shape, but you can kind of get an idea of eventually, once you start making these more and more complicated parts, you really just want to draw in that construction geometry and dimension off of it. This is a good use of a construction line. Cool. So I can dimension not just off of between here, but I can draw on this vertical axis. And one thing that I don't know if you noticed, but I didn't actually go in and make a vertical relation here. So SolidWorks will automatically, if you're starting to draw in, kind of make a center line. So for construction there, if I'm drawing in a horizontal line, you can see right by my cursor there, a little yellow line, horizontal line pops up. I click that down, exit out of my line tool, it automatically added that in for me. And so SolidWorks will do this. You kind of have to watch your cursor sometimes to see that little yellow box pop up to show you, hey, I'm adding in some relations here for you, just so you don't have to do them later. Vertical and horizontal are the two most common ones that you'll see happen. And then if I remember right, I think if you don't want to see that relation, you just click or have that relation automatically added in. You just hold Control as your as you're plopping that line down, and it won't snap to that horizontal line. So that's just a little tooltip there. All right, so now moving on, let's say that I don't want to actually dimension this edge here. I want to dimension the overall height of the parallelogram. So there's a couple of different ways I can do this. One way is to just dimension the distance between two lines. So if I click two parallel lines, you can see that the dimension that it adds in isn't an angle dimension like what we were doing over here before with the 32-degree dimension. We're actually, two parallel lines, it gives you a dimension to add in. And, again, let's say that I want this to just be, instead of that edge being 20, I want the overall height to be 20. And you can see that kind of shows you, those dimensions get dragged, or the little dimension the extension lines there. Kind of show you that, we're dimensioning from this edge to here. But there is another way that we can do this. Again, kind of by adding in some extra construction geometry. Add that in there. And then I will show you guys another relation that we can use. Haven't gone through and talked about all the relations between lines yet, but this collinear relationship here, add that in. This means that both of those line segments lie along the same long line, so they're both have the same direction to those. You can see that as I drag one of these points, it drags both of those lines and they stay together. And then I can just dimension that this construction line is 20 millimeters long. And now, so this is 20 millimeters long, so that means this line here, 20 millimeters away from there. So now I actually have a physical piece of construction geometry within my part file that shows me the height of my parallelogram. So I can do that there, kind of to tie in with the overall theme of adding in relations. I'm going to make another construction line in here from that point down, and I'll try to not add in a bunch of relations here just so we can go through and I'm going to click that line that I just drew in, click that other one, and I can make them perpendicular. So now I know that, again, that's the height of this parallelogram. So even if if this line wasn't horizontal, which I guess I can make that happen here. There's that horizontal relation. Delete that. I'll drop that down there. The parallelogram is no longer horizontal. Maybe I'll dimension that it is, let's see, let's put that there, 105 degrees off the vertical for that bottom edge. You can see that because we dimension this construction line here as vertical, instead of dimensioning it to the bottom edge, it's still hanging out over there, which can be useful. Again, we're kind of using that line now to orient how our parallelogram is facing, but this line is now perpendicular. And then if I go and dimension that line, let me fix that real quick. We'll talk about that here in a second as to what kind of dimension that is, but there we go, 20 millimeters for that new construction line that I drew in, and no matter how much I change this angle, still going to be 20 millimeters there. Cool. And again, that's kind of where that is being, let's see, 100 there. Cool. So we can kind of see, as no matter how much I change up all this stuff, that line is always going to be perpendicular to the base, and then I can get my height of my parallelogram. Alright, so let's roll back here. I think that's all I had to talk about with this parallelogram example. So I'll kind of give you some other options here with our different line segments. So basically line-to-line relations. Remember, if we have two lines that aren't parallel, dimension between them, it's going to give me the angle between them. And then if I select both of them, make them parallel, that's going to give me the distance between. Cool. Delete that. And then let's talk about the other line-to-line dimensions. So we have collinear, which we've already talked about. They both lie along the same line. Perpendicular means that they're perpendicular to each other. We also have equal, and that just means that the length of the line itself is actually equal for both of them. it's the length value specifically. So these can be in different planes, different orientations, whatever else, but they're going to always maintain the same length. No matter how much I drag these points around, always going to be the same exactly. So if these are both 20 millimeters, or if this one was 20 millimeters, that one would be 20 millimeters as well. So those are line-to-line dimensions. We also have a couple options for point-to-line dimensions. So this line here is parallel. I'm going to get rid of that dimension here just so I can kind of show you a few things. Rotate that line around. Cool. So point-to-line. So if I click on those two, so that point, the end point of this line, and this line here, I have a couple options. One of them is coincident. So that coincident relation just kind of lets me, or makes it so that that point is always along the line itself. So it's just kind of, you can kind of see as I drag that point along, it's always going to be there. If you notice as I drag it off, it's still kind of along the same direction. Doesn't necessarily have to be on that line segment itself. It's treating it as a line of infinite length, and then that point's always going to lie along there. The other option that I have is to make it a midpoint. So that means that that point is always going to be in the middle of this line, no matter how long or short I make it. And you can see that by dragging that, I'm actually changing the length of the line itself. So the dimension from this endpoint to the middle is always going to be the same as from the midpoint to the other endpoint. I don't notice that I don't have to do both a coincident and midpoint relation. I just need to have a midpoint on there. The only relation that you really have between 2 points, so I just kind of dropped in a point there and this other one, or actually you have a couple of different options. So horizontal, vertical, and coincident. So coincident is the main one there. If I wanted these 2 points to be at the exact same XYZ coordinate, that's what I do for coincident. But also, one of the handy things is that you can make them horizontal to each other. So without actually having to go in and draw in construction geometry, you can make these two horizontal to each other. In general, you have to kind of have a little bit of judgment here. It would be helpful to actually have that construction geometry in there. If I just open up this sketch and it looks like this, and there's this point just floating here, I don't know what it's referencing to when I start dragging stuff around. I mean, when I drag stuff around, it kind of shows me, oh yeah, here, this horizontal to that. But it's better practice to actually go through, draw in the construction geometry, so that you have that kind of visual cue that, hey, this is pointing to this other point, and then this construction line is actually what's horizontal. So since both those points lie along the line, of course they're going to be horizontal as well. Now, getting into arcs. Arcs and lines, they have a couple of different relations. So if you remember, I think I showed this earlier on, the ability to sketch an arc right from the line tool. So we have a couple of options. There's our tangent relation. So if I didn't have this one already in there, and I went and dragged this around, you can see it's not tangent anymore. Click the line and the arc. Gives me the option to make it tangent. Other thing that it lets me do, the other kind of the relation that I can add in here is a equal curve length. So basically if I were to draw, I guess it's better drawn with like a circle. So there is my circle, and there's a line, just arbitrary line, arbitrary length. So these two, a circle is basically an arc that goes around and shares two endpoints. So if I make these two equal curve length, it just means that this wheel, or the circumference of this is the same as the length of this line. And basically if I were to roll a wheel around a full revolution or unravel it, it would be the same exact length. And from basic geometry, we know that this line, if I were to kind of find or to define, here I'll just do it. So 4 is our diameter, And there is our pi times our diameter. There's our length. So that's just a quick little demo there, but that's kind of how you think about equal curve length. If I were to flatten out this line and it wasn't an arc, it would be that length there. And then we have a couple relations that we can do between different arcs. I'm going to use circles here just to represent arcs. It's a little bit easier to visualize a few things. So same thing, still have that equal curve length relation. Actually, there is one thing that's going to be easier to show from some 3-point arcs. Do something like that and something like that. Cool. So if I were to click on these two arcs and make them co-radial, what this does is it makes it so that these two arcs both have the same radius and same center point. So you can see that no matter how much I drag this around, drag this around and make this a whole circle, but this line isn't just going to have the same value for its radius, it's actually going to have the same origin for its radius as well. It would be kind of hard to show with two circles because they just basically be right up on top of each other. But other than that, the other ones should be straightforward. Tangent arcs. At that point right there, they touch and go on their merry way after that. Then we have concentric. So that means that the origins of those circles are in the same point. That's a fairly common one to use. And then equal dimensions for that radius, the value of the radius, but not the same origin like you would with co-radial over here. So that's what we got for those two. Let me just double check, make sure that I'm not missing anything. And we still have the option to do equal curve length as well. So with these two co-radial arcs, if I do equal curve length as well, they are now equal arcs. It would be the same thing as me kind of saying equal relations on them. Yeah, so that's what we got there. And I guess I should kind of clarify that. So the only reason that me adding equal curve length to these two would be the same as doing equal. Equal means that it has the same radius and same curve length. Or sorry, equal means, yeah, so it should mean equal radius and curve length. In this case, we got those two as equal, and then we had these already set as co-radial. And then we made them equal curve length. So same radius, same curve length. No matter how much I drag them around, now I just have to fix the position of them. Hopefully that's fairly clear. All right, so I think that covers all of our kind of basic relationing there. So we have kind of just basic relations for lines themselves. They can be horizontal, vertical. You're basically doing line-to-line relations at that point with your origin. So your coordinate axes that are set up for you automatically. Then we have point-to-line relations. They can be coincident, so just lying along that line. It can also be a midpoint, like we were showing here. Arc line, you got tangent, you got same, equal curve length, and then arc, you have your co-radial, concentric, equal curve length relations, and that kind of stuff. So that's everything for relations. Let's clear out our sketch and we can talk about some other dimensions. So for the most part, we've talked about, I think I'm going to do one of these here just to illustrate a few points. Cool. So we've talked about basic dimensions, the way that most people would think about them. All right, this line has this length, 40 millimeters, that specific line. But there's a couple of different other dimensions that are dimensioning types that we can do. So we have this here. This here is going to be our vertical dimension. So it's a dimension between those 2 points that I just selected. Or actually, I think I just selected the line. Let me just double check, make sure that I did that right. So yeah, if I dimension the line and I drag off to the side, it's dimensioning between the two endpoints of the line in the x-axis dimension. So it's useful for like triangles. If you just draw the hypotenuse of the triangle, you can think of this as dimensioning the two legs of the right triangle. So 30 millimeters high, for example, and you can see it. The point. If I were to draw in some construction geometry here, a vertical line and a horizontal line, make sure, yeah, and then I can kind of measure that line there to be 30 millimeters. It'll show me that that's the same as that. All right, so we got kind of horizontal or vertical dimensions. Same thing goes for horizontal. Just remove that extra geometry there, or extra topology technically, but there we go. Same thing, you can do it in the horizontal dimension. So that's fairly straightforward as well. We also have dimensions for arcs, and I can kind of show you here. Remember when I was saying that shaft that we were making with the keyway through it? I dimensioned this guy here to be 25 millimeters. Let's zoom back in, drag that over. And then, so normally if I don't press any mouse buttons and I click those two, it's going to try to dimension that line from the center of the circle. It's not always what I want to do. Sometimes I want to dimension just how much material I'm cutting away. So that dimension is starting to pop up there. The way that I'm getting to that is by holding down the shift key. So we're going to remember, if I were to just click on that, it goes to the radius. If I were to click on that while holding the shift key, it gives me the angle or the dimension closest to that side of the circle. If I were to hold the shift key and go out here, it's going to give me the opposite. So it all kind of depends how you want to communicate the same information. Either I'm cutting away, as we were doing before, 3 millimeters, or I took this shaft and I measured from modeling a part that's already being manufactured from somebody else. Purchased a motor off the shelf and it has a keyed shaft, and I measured from the flat down to the other side of the shaft, and it's 22 millimeters. It all depends on how you want to communicate that information, but also it's helpful for, let's say that we have two circles here. I'm going to draw a construction line going through the two origins, make it horizontal, and over here my checkbox is for construction. And let's say that these are two shafts of the same size. So again, a little bit of practice with the relations, make them equal. But and I need to measure how far apart they were, and I took some calipers and I measured from the outside edges, so from here to here. Kind of, if I click these two circles, and I don't want to do, I'm an engineer, I'm lazy, I don't want to do extra math that I need to. That's just to make it easy. It was 100 millimeters between the outside edges. These are 25 millimeter pieces, so it should just be 75 millimeters, right? But again, I wanted to reflect how I measured it, and kind of my design intent. Maybe those two shafts can't be, can't span overall more than 100 millimeters, just because of packaging their stuff outside of them. So again, by holding the shift key on one edge, so that edge closest, and then that edge over there. So now I have my two outside edges. Pop it down, 100 millimeters, and you can see where those dimension lines are dropping down. I can do the same thing if I remove that, and instead of measuring the outside edges, I measured the inside. Get that dimension out of the way. Pull that back up. So click towards the inside edge of the circle and the inside edge of that one. You'll see it starts to pop up. 40, let's say I measured at 50, same kind of geometry, and there we go. Maybe these are two holes, and I just stuck my calipers in there and measured the smallest distance that I could. You can also combine the different kinds. So let's say that I just normal clicked on that one, starting to measure from that center point. Shift click over here. See, it's measuring from the center point of one circle to the closest edge, or to outside edge works as well. So I can combine both those different types if I wanted to. So those are, that's how we kind of can mess around with arc dimensions. It's a very handy tool to be able to use, again, because we're not, it's very hard to measure this, where the center point is, and on a hole or on a round object. We could scrap some stuff with geometry and or geometrical concepts that we probably all learned in middle school or early high school. But sometimes it's easier to just take your calipers, put them on the outside of your shafts, and figure out, or whatever other rounded object you have, and dimension from there. All right, so we've talked about horizontal and vertical dimensions, and so far, we've kind of just been using the smart dimension tool. If I get rid of this stuff, and I'll kind of set up the next part that I've wanted to add in here. Cool. So I'm just going to make something that looks like that. And, again, the smart dimension thing, we in the drop down, I guess we can't even see drop downs on there. I just realized that. So we have a couple of things. Hopefully you guys are following along. We have smart dimension, horizontal, vertical, which we've talked about, how to get to those from smart dimension. But if you're making a bunch of the same dimension, or a bunch of the same dimension type, sometimes you don't want to mess around with kind of fiddling with the smart dimension. Just kind of click on whatever else. Let's say that I want to dimension the horizontal distances between all these. Click on horizontal dimension. That way I know that every time that I click, it's giving me a horizontal thing. Versus if I were just use smart dimension, I'd have to go and kind of drag over so it looks like that. And then on this line that I know isn't horizontal but is very close to it, I have to kind of, it's only off by like 0.1 millimeters or whatever else. So it kind of helps sometimes if you're going to be doing horizontal dimensions, just click on the drop down, get the horizontal, and then that way, no matter how hard or how you drag. And same thing with vertical, right? So the next one we're going to talk about ordinate dimensions. So this, you can kind of think about setting an origin and dimensioning how far away you are from that origin. Or I guess a baseline is another term that we could use. So here is our our baseline that we set. So we click on the first line that we click on. It's going to give us a 0 value. I can place that wherever I want. I'll put it over here. Then every line that I click on afterwards, it's going to give me the dimension from that 0 line down to it. So this line here is 37.09 millimeters away, the way that I sketched it in, and so on and so forth. And then after I exit out of that, I can go in and adjust all those. So that's actually 25, this one's actually 50, and then this one's 100 because we're skipping one in here or whatever else. But I have that option of, again, it all kind of depends what my design intent is, how I'm measuring things if I'm modeling a part in the real world, or what my constraints are, how I'm going to be giving this to a manufacturer. If I'm making a bolt pattern and the bolts have to be spaced out every so often. If you've ever used a mill before, you're going to have a digital readout. And then you set your origin, and then you go over, you travel 25 millimeters, drop down a hole. And then instead of just dimensioning, oh, hey, go another 25 millimeters, the machinist then has to do the math as well. They're probably just as lazy as we are with basic arithmetic, and don't want to go through and be like, all right, 25 plus 25, that's 50. Okay, cool. I'll have to go to X50 and then drop this hole down. And we can do, with that ordinate dimension, we can kind of do the same thing and make it, specify that it's horizontal or specify that it's vertical. And then there's a path length dimension, which we won't talk about because that's very rarely used. I personally haven't used it myself in my last 5 years of using SolidWorks. But, kind of as we were talking about before with the arc lengths, that's where you'd use a path length. It's that equivalent line that we're drawing out, and that's how long, that's how long it's going to be. So that's all of our dimensions there. We can kind of start to talk about patterns now. Let's see, let me get another drink real quick. All right, so patterns. Let's say, this the most common use that I found for patterns, or I guess a good way to describe patterns would be to think about doing a hole pattern. You have a pattern of different size holes that you're going to be fastening bolts through. You need several of them because maybe you're clamping something to seal it shut, whatever else. Very rarely are we just using one bolt, but I want you to imagine kind of a 3x3 square of holes. They're all going to be 1/4 inch holes, be spaced apart 1/2 inch from each other. And then it's a 3x3 square, but we don't want a hole in the middle. We just basically want 8 holes in a square, 3 holes, then going up and around. So what I can do is I can go through and actually draw in each of those individual 8 holes, make them all equal to each other, dimension the distance between all of them, and then dimension the angles between them. So vertically they'd be, or going up they'd be vertically all in line, and then going across they'd all be horizontally in line. I don't, again, I'm lazy. I want to speed things up. So we have patterns for that. So start off with our 1/4 inch hole for our bolt. And usually, it wouldn't actually be exactly a 1/4 inch, depending on the kind of fit you have. But anyways, again, we're gonna have to set our scale here and scroll in a little bit. But here's our 6.35 millimeter hole, which is a 1/4 inch translates to, and centered around the origin. It could be anywhere else. If I didn't draw this at the origin, I'd have to dimension how far away it is from it or to some other part geometry that I have. But right now we have a fully defined sketch, and our goal is a fully defined sketch of 8 of these holes here in the pattern that we want. So we'll talk about a linear sketch pattern. Linear because kind of the axes that we're thinking about, we're patterning along the x-axis and along the y-axis, or technically what we're looking at here is the xz plane, but kind of on the sketch, this red origin here is your x and your y axis. You can kind of think of it that way. So we're going to select, usually the first thing that I'll do is I'll just drop down into entities to pattern, click on the thing that I'm patterning, and that way it'll give me a preview of what I'm doing as I'm doing it. And then we can kind of work through things. So our direction 1 is our x-axis. You want it to be horizontal. If I didn't want it to be horizontal, like I wanted it to pattern at an angle, I can change the angle down here. But I do want it to be horizontal. Click it at 0. And then it's going to fix the x-axis direction. If I wanted to later on, I can uncheck that, and then I can go in and make it horizontal. But I'll just go ahead and click that, fix x-axis direction. Then I want to, remember we're doing 1/2 inch spacing, so 0.5 in. Nice thing about SolidWorks is it does all the unit conversions for you. And then we look at, all right, so 3x3 square with the middle one missing, need to pattern 3 over. And then this checkbox for display instance count, we'll leave that on. I'll show you what it does, or kind of where it'll show up in a bit. So we've got our 3 holes going in our x direction. Now we want them going up in the y. So I scroll down to our direction 2, and our linear pattern is limited to only 2 directions here. So that's something you also have to keep in mind. If you have a really complicated pattern, sometimes it might take a couple of sketch patterns to do. But we'll go with our y-axis next. So right now I just have 1 instance count, so only 1 row of these holes. I want 3, so click, add it in. There's my 3x3 grid of holes now. Then here's my angle. Kind of before it was just the angle off of the x-axis, and now it's the angle between the axes. So right now, it's I can kind of adjust this again if I needed to skew it. But really, I want this to be perpendicular to the other one, and I want to dimension the angle between it. Later on, I can go and add in that angle myself. But again, save steps. Much rather have the software do it for me. Leaving display instance count on, and then again 1/2 inch. And then this other checkbox, I think that I forgot to mention, dimension X or dimension Y spacing. That just adds in a dimension, again, that distance dimension between each of these instances. So I want to go ahead and add that in, because again, our goal is to have a fully defined sketch at the end of this. And then that kind of covers both of our directions. Going down at the end here, remember we wanted to skip that middle one. We don't want a hole in the middle. I'm going to click in this box. It's going to bring up these little pink or magenta dots at the center of each of the instances that I'm patterning. And then I'm just going to click on the middle one. You can see it disappears from the preview. So regardless of what kind of shape you actually have, the dots will pop up kind of at the origin of where these pattern lines are coming from. So in this case, they're starting at the center of the circle, so all the dots are going to be at the center of the circle. So I can click that, get it out of there, and you'll see that it pops up as 2, 2. So it's the second instance over on the X and the second instance up on the Y. So that's that. Then I can go ahead and got everything set up here. Click the green check mark. Still have a fully defined sketch. All these things are black, so I can't really drag them around. There's my angle between my axes. There's my Y spacing. There's my X spacing. Here's my X instance count, so it's showing me there's 3 of these in the X. Here it's showing me there's 3 of them in the Y. I can double click on them to change them, so they work just like a normal dimension. Undo that, and then I don't actually need to have this 90-degree dimension here. So if I know that these are going to be always perpendicular, I have these 2 lines here. So these are the 2 lines that actually define your linear sketch pattern. Remember, it's linear because they're going along certain axes. I can go through and make them perpendicular. Sorry. Perpendicular. Also, the length of each of these lines corresponds to my spacing in that direction. So if I knew, again, that this is always going to be a square kind of pattern, equal spacing both in the Y and the X direction, I can get rid of that. See, those become blue now because I can drag them and change my Y spacing. So I'll click on these 2 lines, go over, make them equal, and now everything is still dimensioned. And I have just this one value here. Say that I wanted it to be 0.75 inches spacing instead of half an inch. Boom, got them all updated. Updates both X and Y for me. Just again by creating those relations between those 2 lines, because these are what control our spacing. If I click on one of these circles here, you can see over in our relations section that says pattern 0. So that's our it's our pattern number. It starts at 0. And you can see if I click on that relation, it highlights all the things that are part of that relation. It's all 8 of those circles. So that covers our linear sketch pattern. Say that I wanted a circular pattern of holes. So start with my bolt hole, also going to be 0.25 inch hole. And then I'm going to dimension, I'm going to add in that construction line first, from the center to the origin. It's horizontal, dimension that line. It's going to be half, I'll make it an inch, so 1 inch. And we're going to pattern it around the origin. So this circle is going to kind of go, or the bolt pattern is going to go around like that. So in my linear sketch pattern drop down, there's a circular sketch pattern too. You guys can't see it on the stream, but we're working on solving that over the next week or 2. Same thing, I'm going to start by clicking my entities to pattern, click on that guy. Then it auto selects a point for me based on what it thinks that I want to do. So here's this 0.1. It is the origin, so that's actually what I want to do. You can see that it starts to draw in the circle for me as well. That shows me the circle that it's patterning along. You can see up here, there's an arrow that shows you what direction it's going in. So it starts with this as our 0 entity. There's our first entity, second entity, and third entity patterns for a total of 4. And we have a couple of options here. So here we can kind of move that point along that it's patterning around. It defaults to the origin when you don't have anything else pre-selected. Move that along. So if I wanted to pattern it, around a point that's 10 millimeters along the X, I could do that. I'm just going to leave these as they are. Sorry. And then we're looking at these, how far around that circle goes. So right now we have an equal spacing linear or circular pattern set up, and it's basically equally spacing all of these pattern entities around a circle or around an arc, technically, of 360 degrees around that point. So if I were to drop this down to only 180 degrees, you can see that it's only going to go 180 degrees on that arc, and then pattern 4 total entities that are equally spaced apart along that arc. And I have my other option to dimension my angular spacing. So now it's 60 degrees along this arc, and every 60 degrees it'll plop another entity down. So I could make kind of wacky stuff happen by doing 100 degrees. I guess I can only do between. That's really weird that it only lets me do that. That's fun. All right. Okay, there we go. So I can start to space things out, and you can see that it's adding in just a little bit there, a little bit there, a little bit there, and it's not equally spaced around this arc. I can also switch back 360 degrees. Sorry, 360. And then go back to just 4 instances to show you here. Or I guess I can plop up. Let's plop up to 6. I think that's what I used in my last example. So 6 circle or 6 holes going around a hexagonal pattern. I do want to dimension my radius for this circle that I'm drawing. If I did, or actually in this case I don't, because I've already dimensioned it here. I already dimensioned that line that I want to use. But if I didn't draw that line in and I just had this arbitrary point and that circle that's going to get patterned around, I don't want to dimension that radius. So in this case, I'm not going to dimension my angular spacing. If I wasn't doing an equal spacing pattern, I would want to add in every 60 degrees and have it actually tell me that. And then there's my radius dimension. There's my angle of the arc. That's really weird. I wonder. Oh, yeah, so that kind of moves that down. Let's see, if I were to set it at 0 degrees, it'd go that way. 180 degrees back from it. And I'll actually drop this down a little bit to there, just so we can go and add in a relation. You don't have to do this, but it's just to kind of illustrate a point here. All right, and then I also have my option to skip some instances. So in this case, let's just say that I want to make something that looks like that. And so here's my point that I am patterning around. That's that point that it added in for me. If you remember, I want that to be around the origin. I've already dimensioned the arc length or the radius of my pattern. So I want to go ahead and make both of these coincident, just like that. There's my instance count, 6 instances evenly spaced around that radius. And there we go. And we skipped these 2 instances here. The interesting thing here is, let's say that I wanted to make this 8. Kind of looks kind of wacky, right? There's these 2 instances that it skipped, and we'd think that maybe these 2 would be based on how we did it earlier. But what it's actually doing, if you remember to that circle that we drew, or that it drew for us, it went counterclockwise, with that arrow at the top, it's skipping the 2nd and 4th instances around that arc, not actually, not around this horizontal line. It's going through and plopping 1, 2, 3, 4, 5, 6, 7, 8, and 8 entities around. And so it's skipping the 2nd and the 4th. So going back to 6, actually I'll see if I can't just bring that circular pattern back up just so I can illustrate that again. 6 instances to skip. Click on that. And I guess that actually calls out the third and the fifth. So this one here is the first instance, and second and third. And if I hover over that, and you won't see it on the stream, but it shows 3. Hover over that point, it shows 5. So if I were to change and increase the amount of spacing that I have, it's going to still skip just the third and fifth entities. All right, so I think that's all we had for patterns. Actually, what I did want to do was recreate that pattern to show you guys mirroring here. So I'm skipping those two. Check. Move that over. Get that point. Make it coincident. Boom, we got our pattern. All right, so let's say that I had something that looked like this. So just these 3 holes. And I wanted this to be over here. Well, I can mirror it over this line here that I have in the middle. If I didn't have the line, I'd draw in, sometimes we have symmetrical parts or semi-symmetrical parts. There's certain parts of it that are the same across a neutral axis. So we usually want to draw in that, not usually, we want to draw in that neutral axis so that we can add in symmetry to our parts. So if I click on this and click on this line, click mirror entities, that just mirrors the part over for me. But just to kind of illustrate the behind the scenes stuff, so I'm just going to click on mirror entities to mirror. I can click all the stuff that I want to mirror, and it's going to mirror them about this middle axis. So there's my neutral axis. If I want to mirror a bunch of other stuff, like let's say I had stuff here, just click in that box, add in a bunch of stuff. And then this check mark here for copy. So if I uncheck that, what it's going to do is just move this over that axis over there. It's not actually going to create a copy of this circle and put it over there. It's just going to move that over. See what it did there, right? And you can also see it's underdefined because it doesn't have anything to reference to for its position in space. So if I wanted to actually mirror that, and mirror it about this axis, I do want to copy it. Now you can see that's fully defined because it has this new type of relation that we haven't seen yet. It's a symmetric relation. We can add these in by hand. We don't actually have to use a mirror tool to add those relations in. We can, if I just wanted these 2 circles to also be symmetric around that, click on the 2 circles, click on the line, and it gives me the option to add that symmetric relation myself. So as I drag these around, or if I dimension one of these to be 0.5 inches, they're both going to change. They're both going to be symmetric. Any changes that I make to one will be reflected on the other. And then if you remember, when I made that mirror the first time, I just clicked on the, I guess I should draw in something else here just to show you what we can do. So I'm going to click on the 4 pieces of the rectangle that I want to mirror into the circle, and then I'm going to click on the center line, and then I'm going to click mirror entities. The key thing here is that if you're going to do this without bringing up the tooltip, kind of in this fast way, is you only want to select one construction line to mirror over. That's basically what it does. Is it out of the stuff that you select, SolidWorks picks out the construction line and it assumes that's your center line that you're trying to mirror things over. So if you think back to when we were creating our lines, and the drop down the center line, again, it's just a simple construction line that it's making, but you can kind of think of it that way. Anytime you're plopping down or you're selecting a construction line, you're selecting it as a center line for the mirror entity's operation. And same thing as before. If I drag this rectangle around, it's going to change on the other side. The circle's already fully defined, so it's not going to do anything. If I delete one of these, it's not going to affect the other. If I deleted this one, it's going to affect the relations on the other, the dimensions, stuff like that. But that's what we have there. All right. One other thing that I should probably touch on real quickly, and this is actually something that I didn't cover in the lesson, in the lesson earlier. So I have a center line here. Say that I have, kind of thinking of it, thinking of this construction line as an actual center line, thinking back to that cup example. I guess that would be a good way to do it. Let me go ahead and just clean this up real quick. Cool. So we'll get rid of that, make a construction line going through the middle of our glass, and then we just have the outside wall here. One thing I can do with dimensions with a center line is, let's click that point there. I'm going to dimension to my center line here, and this would basically be a radius dimension, right? So going from the middle out. If I drag this dimension over, you can see that it fakes in the other side. So I don't even actually have to have the other side of the geometry added in there yet. I can just drag this dimension over, and there it is. It's giving me a center line. So let's say that that's 40 millimeters. And then one of the other things that SolidWorks does, if you look at my cursor, it has the dimension icon right next to it, as well as D and a construction line. So it's automatically going to add in any other dimensions that I want. As I go through here, it's automatically going to assume that I want to do a dimension, diameter dimension around that center line that I selected already. So, and that is the case, 30 millimeters. And then now it's going to give me the option to do an angle to that center line, and still kind of referencing all these dimensions that I build off of that center line. Maybe that's a 10-degree draft on that. Cool. So it's pretty straightforward. If I wanted to exit out of that, you just click escape once, and it'll just go back to normal dimensioning. And then to get out of the dimension tool entirely, click escape twice. All right, I'll probably have to review that with everybody who attends in person next week, but moving on. The last couple of things that we should talk about with this sketch toolbar is move entities and this display delete relations toolbar. So move entities is a tool that, with good design practice, you shouldn't really have to use it. Basically, if I draw this circle here, draw the circle in around the origin, 10 millimeters. Move. Again, we won't see it in the drop down, but move, copy, rotate, scale, and stretch entities. So basic, rudimentary transformation operations on our geometry if we don't want to go in and add in the construction geometry ourselves. So move this entity here. Click on the entities to move. Keep relations. I want to uncheck that. If I try to check it, it's going to try and keep placing it at the origin because it has a coincident relation with the origin, right? So I don't want to keep those relations. I want to move it. Here's my delta x, delta y. So how many millimeters am I moving in the x? How many am I moving in the y? Could also use start point and end point, so I can click an actual point, a reference point here. And then if I had a point somewhere else where I wanted to move that to, do that. But in general, it's fairly simple to add in another circle and just draw it in there. But just to kind of show you here, 20 millimeters in the X and 30 in the Y. Boom. Doesn't have any relations, doesn't have any dimensions. So you can see why this isn't really a great tool to use. There is a time and a place for it, and it's very, very rare. Again, most of the 99.9% of the parts you're going to design for the team, maybe I shouldn't go that high, maybe 95% of the parts you're going to design for the team won't need to use move, copy, transform, stretch entities. You can just draw this stuff and with your basic geometry, just add in another circle there, delete your first one, add another one in, dimension it, add in your horizontal dimension here. It's 30 millimeters away that way, and then it's 20 millimeters away that way. Cool. Now it's fully defined. You have your dimensions there. You don't have to use that move tool, but it is there. If you find a need for it, let me know. Because like I said, in 5 years I've used SolidWorks, I've very, very rarely touched that tool. Yeah, and then display delete relations kind of just shows me the relations that I have. If I have a fairly complicated sketch, it can kind of show me, all right, here you have this vertical, symmetric, horizontal, angle relation, equal length, all this stuff, kind of show it all there. But one of the things in this drop down, let's see, I'm just going to draw some lines here. This is if I in this drop down now, I have an option to fully define my sketch. And kind of like with the fixed relation, I want a lot of you to pretend that this button doesn't exist, just so you get the practice of fully defining your sketches intentionally rather than letting the software do it for you. So, drew in these 3 lines, draw this line over so it's horizontal, drag this line over to where it's vertical, and this, I want this one to be horizontal too. Go through and dimension 50 millimeters, 25, and 45. There we go. All right, and for some reason my sketch isn't fully defined. I thought I drew everything in, and this line is horizontal, that line's vertical, that line's horizontal. What's going on? There's a couple ways to solve this, or to kind of figure out what's wrong. One of them is to grab one of these points and just drag it, and you can realize that when I dragged those points, didn't actually add in those relations. It just kind of placed things in a way that looked horizontal. And if you remember, when I dragged that point, those little icons that popped up, they're in white. They're not in yellow like they were when we were actually drawing in. You can see that that tooltip is yellow. That's drawing it in and actually adding in that relation for me. But this is a fairly simple situation of, hey, essentially what it boils down to is I can't figure out what's wrong with the sketch. I don't know why it's not fully defined, and I want the software to fully define it for me. So in this fully defined sketch thing, we have a couple of things here. We have all the entities, kind of our scope of this. If I just want to define these 3 lines, I can go in and select them manually, or since they're all the only things in the sketch, all entities in the sketch works. And then I have 2 options here, relations and dimensions. So if you remember, usually we want to add relations to our sketch and then go through and add in all the dimensions for it. So usually my recommendation for this is, if you need to use this tool, just to use the relations portion of it. It's fairly easy to see all of your dimensions within the part or within your sketch, and just to kind of be like, yeah, I thought I dimensioned everything right. So I'm just going to calculate relations. If I wanted to have it add in dimensions for me, I'll kind of show you an example of that here in a second. But just calculating all the relations, you can see the lines are still blue. It's just a graphical error within the tool. But down here it says fully defined. If I click on one of these lines and try to drag it, it should update here. There it goes. Updates to all the lines being black. And again, what it did, add in a vertical one there, horizontal there, horizontal there. And it kind of auto-calculates these things for you, and it takes its best guess at what needs to happen. But if you remember to the parallelogram example, if I wanted to say that these 2 lines are always parallel to each other, right now they're horizontal, but what if I angled one of these down? This one would stay horizontal. It doesn't know your design intent for you, so try to avoid having the system do stuff for you, and actually go through the work of putting in your relations and your dimensions yourself. But to kind of show you what it'll do with automated dimensions, just do 5 lines there, fully define our sketch, dimensions as well. So there you go. Just dimensions everything from the origin. Doesn't use an ordinate dimensioning scheme if that was important, or anything else. You might as well just click on the line and call it a fixed geometry line if you wanted to. That being said, you could potentially use this if you kind of drew your topology and you're like, all right, what are the dimensions that I need to make this a fully defined sketch? Like I kind of drew a shape that I saw in real life, and it's like, all right, well, what do I have to go measure on this now to make it fully defined? Then I go out and I measure the shape, and it's like, oh, this is actually 95 millimeters, and this is 66, and whatever else. I can kind of do it that way, but it's not quite. You're letting the system do a lot of work for you, which can get really messy and really convoluted. This is just a simple case of 1, 2, 3, 4, 5 lines, and it added in 8 dimensions for us. It's a lot better to just draw in that stuff yourself and go through the thought process. It's kind of what makes CAD hard to some extent, and kind of thinking about parts in 3D, but definitely want to go through that process. All right, that being said, I think that's all the individual sketch stuff that we have to talk about. now we're going to talk about multiple sketches and using existing part geometry to kind of to do stuff with it, basically. So in this case, I'm just going to make a square here just so we can make some, give you as an example, make it a 100 millimeter square. And next week we're going to talk about how to turn those sketches into 3D parts. But we're going to extrude this square 50 millimeters up. And then let's say that I want to create another sketch on this face now. So I'm not doing it on one of the reference planes, front, top, right plane that get added in automatically. I'm going to click on this, go over to my sketch toolbar, click sketch. And now I'm actually sketching on this face here. So if I just draw a random circle just to illustrate, see it's on that face itself of the sketch. And you'd see my of this box, and my sketch origin is right in the middle of that face now. So I'm going to right click on the sketch, click on normal 2 to get back to that normal view, and I'll delete the circle. But let's say that I wanted to bring in this face and actually these lines on the outside to use in part of my sketch. So a couple ways to do it. Convert entities is the main tool for this. Entities to convert are my, going to try to get all these lines in here. See, those are the edges of that face. And if I click the check mark, it brings in those 4 edges individually. What I can also do, if I'm just doing this face itself here, convert entities, just click on the face. It says convert the face. Still going to just bring in those 4 lines for me. And what I can use this for example, is to cut out just a corner of this. Actually, maybe I'll do an extrusion this time around just to show you something different. But this extrusion is going to be 60 millimeters from that edge and then 45 millimeters from that edge. Cool. I'll go and extrude it up. Select that contour. Actually, one thing that I should have done real quick, let me go back into that sketch. So, and I made that there. I'm going to trim away all this excess stuff. And even though this line down here now is shorter than the original edge, it still has this other relation, which is on edge. It basically just means that this line is on the edge of, is along the same edge as this face is here. Or as the projection of that face is onto the sketch plane. So, again, kind of going back, I'm going to extrude, click on that sketch, and we're going to be talking about extruding stuff next week. But this case, another 50 millimeters up, you can see that now this face is all one big piece. It's not kind of stepped out or offset or anything like that. It's actually along that same edge. Now, again, we're going to assume that this part's a little bit more complicated. And we're going to, actually, let me go back and edit that sketch real quick. I'm going to do something here just to illustrate my point. 75. That'll do. All right, so you can see 75 millimeters that way, 60 that way. And let's say that I wanted to do something on the front plane, like I wanted to cut out a hole, or just, again, it's a simplified part. Sorry, I'm struggling for words here, but it's a simplified part. I'm just trying to show you guys the tools here, but we're going to make a sketch on the front plane, and then I want to bring in the cross section of this part. Again, simple part, fairly straightforward. I can just convert this face, but I'm going to kind of illustrate that we're going to bring in the intersection of this part, and it's actually going to be the intersection of these faces here that are going to be brought into the sketch. So you can see them there. And just to illustrate this a little bit better, I can show the front plane. You can see that's where the front plane crosses through the part, and there's the intersection of that part, of the part with the front plane. And then from there, I don't know, let's see, what can I do? Maybe I'll cut away part of it. Yeah, I'm going to cut away from here down there, and then I'll cut away an arc at the bottom here. And I'm just messing around here, but cool. But I don't even want to bother with fully defining these sketches. bad design practice not to. Just illustrating something for you guys here. So, and then I'll extrude a cut, which again, talking about next week. And I'll just cut it out 10 millimeters. Cool. So if I hide this plane now, you can see that from that intersection, I made some geometry where I cut away into the part. So, it's a fairly simple use of that, but it kind of shows that if I have this complex part that passes through a certain section and I want to figure out where it passes through, usually it's going to be for dimensioning off of it, not necessarily for using it to create geometry or cuts or whatever else. Usually it's just to get a dimension off of it, so we'd probably convert those to construction lines. But you can do that with the convert entities, the intersection drop down within that. Another thing to showcase real quick, that I showcased in my other part, if I were to make a sketch here on this plane and I wanted to offset the outside border into the part, I don't actually have to bring in the geometry before I offset it. I don't have to go through and convert the face and then offset it. I can just click on the face itself and then offset it in, and then not create it as construction geometry. And now you can see 3 millimeters off of the edge all the way around, and I can cut that in just to help you guys visualize it. 5 millimeters. So you can see that I offset the face without bringing it into the sketch first. Saves me that extra step. And then just as one last thing, let's create another sketch on this plane here. Let's say that I wanted to create an arc like that, and I wanted it to be tangent to this line. Again, without bringing in the geometry of the sketch, I can still create relations. Hold on. Yes, I can still create those relations there. Drag that in, and you can see that as that comes through, that's tangent to it. There is no line here within the sketch. Sometimes this can be useful just to speed up our design process or something else. Let's say that I wanted this line that's going to come out of here. Now it's going to be perpendicular to this, and then it's going to be tangent to that. And then whatever else. I can also dimension off of things. And usually you only want to do this if it's very clear what you're dimensioning off of. Like, we don't want to do something that's super, super far away or like hidden. Like if I was to draw something on here and I'm dimensioning to that, usually I'd probably want to bring that in, convert it first, either by an intersection curve or just by clicking that edge and converting it into the sketch. But this can save us a little bit of time here. And I think that's really all that I had to talk about. Let me just cut this out again just so we can visualize. And we'll talk more about this later on, but you kind of see tangent there, perpendicular there, cut out, and we've kind of made this wacky looking block here. Yeah, sorry if I kind of rambled a little bit or fought for words, but still looking at how to capture my whole screen and not just the window itself, because that's what it's coming down to within my streaming software, where you guys can't see the drop downs as I'm clicking on them. But next week, or I guess Wednesday, we'll be covering features. So all these tools up here, how to convert stuff from a 2D sketch into a 3D part, and then going fairly in depth into that. But that just about covers all the sketching stuff. And there's maybe like 2 or 3 things that I'll talk about at the start of next class or next session about how, or related to sketching, that mirroring dimension or the centerline dimensions that I was talking about earlier. I do need to review with the people in person. And then there's a few other small things that we'll talk about. But for the most part, that covers all the sketching tools that we use at Viking Motorsports. There's a couple others that we'll cover later, but That should get you started. And for those of you who weren't there in person, as an exercise, strongly encourage you to go into our lab and just model a profile of a part. So maybe look at a wheel center and kind of just draw it out in SolidWorks. And maybe take some calipers to it, add some dimensions, some relations. If the wheel center has some spokes, maybe do a circular pattern and try and figure out how to define that pattern to be a fully defined sketch. But that's just an exercise for you guys. You're welcome to shoot me an email or get a hold of me if you have any questions. But that should be everything for the second half. I noticed that this was an hour and a half long on its own, so definitely got rambly. But thank you guys for tuning in, and I will see you all on Wednesday.